Okay, you sent us some truly mind-bending source material this week, and we have to just jump right in.
We really do. It's one of those things you have to see to believe.
We're talking about the creation of a fully functional 3D turn-based battle game.
And not just some tech demo either.
Exactly. Not a tech demo, but a complete experience. It's got graphics, combat mechanics, enemy AI, a polished UI,
The whole package.
and an AI built all of it, start to finish, in just 30 minutes.
Yeah, the 30-minute timeline is, it's the headline that grabs you. But the real story, I think, the intellectual payload, is the architecture the AI chose to make that speed even possible.
Right.
So our mission today is to go beyond just saying, wow, look what it made, and really analyze the synthesis process. How did it use a modern web stack, we're talking React, 3JS for the 3D, and specifically Zustand for state management, to deliver something this complex, this fast?
It really forces a whole redefinition of what game development even means. You know, it's not about just coding faster anymore. It's about synthesizing a vision, a description, and getting all those necessary pieces at once. So I'm fascinated by that stack. Why that combination? Why React, 3JS, and Zustand? What makes that the perfect AI blueprint for this?
Well, what's so interesting is that the combination prioritizes things that are essential when you're generating something in minutes. I'm talking performance, reactivity, and efficiency.
Okay.
So React gives you this structured component environment that's pretty standard. 3JS is, the gold standard for web-based 3D, but Zustand, that's the really clever move here.
Why that choice specifically?
It's a minimalist state management library. It's all about high performance. For a complex turn-based system where you have, dozens of variables constantly changing.
Health, turn meters, cooldowns, all that stuff.
Exactly, all that. The AI needed something incredibly lightweight and fast. It feels like it deliberately avoided the boilerplate and overhead you'd get with something heavier, like, say, Redux.
So this is more than just coding. This is proof the AI is making critical, high-level architectural decisions.
That's it, precisely. It's engineering.
That makes a lot of sense. It's building an engine that's designed for speed right from the get-go.
Yeah.
Okay, so let's dive into the visuals that this architecture actually produced, because this wasn't just a gray box. The source describes a really polished cinematic arena.
It established a tone immediately.
Yeah.
The environment it created, it's this bright, almost ethereal sky blue palette. You have these soft floating clouds and a central circular stone platform.
With gold inlays, right?
Yeah, with gold inlays. And see, this isn't arbitrary. The AI interpreted a prompt for a high fantasy, clean aesthetic, and it translated that into specific 3JS materials and shaders that give the whole scene depth and luminosity.
And the source compared it to a mini Summoner's War arena.
Which is a perfect comparison. It shows the AI understands genre conventions and how to achieve a certain feel through geometry and texture. It's not just making a thing, it's making a thing that fits a style.
I hear you on the synthesis, but I have to ask. How do we know it wasn't just, pulling pre-made assets from some huge library? Is the complexity in the modeling, or is it somewhere else?
That's a great question. The complexity is really in the integration and the movement. The source notes that the two monsters, Ignis, the fire dragon, and Frost, the water chimera, they were built from pretty primitive shapes.
Okay.
But they felt fully realized. Ignis, for example, had flapping wings, this constant floating idle motion. Frost was bigger, heavier, so it had this really distinct heavy breathing animation. The AI used the 3JS ecosystem to apply complex transformations to really simple geometry.
So it's all about efficiency.
It's pure efficiency. You don't need these incredibly high polygon models if you can sell the illusion of life through movement.
Let's zoom in on that movement, because this is where the polish really separates a quick demo from an actual game, right?
Yeah.
The source material mentions spring physics for the attacks. What does that actually mean in terms of code complexity?
That's a critical detail. A simple linear attack animation is, well, it's easy. But implementing spring physics means the movement has life. It's not rigid. It has acceleration, deceleration, a little overshoot like a bounce or recoil effect.
It gives the lunge some real weight and impact.
Exactly. The AI had to define specific spring constants. things like stiffness and dampening, and apply them to the monster's position when an attack starts. That means it's calculating physics in real time, integrating that with the 3GIS render loop, and making sure the state in React updates when the attack is done. It's a tiny detail that requires a really sophisticated understanding of how animation works.
And that level of detail goes into the feedback loop too, right? The hit, reactions,
Yeah.
a red flash, and screen shake. I mean, aren't those just gaming cliches at this point? Is the AI just leaning on tropes to save time?
That's a fair point. They are tropes, but they're tropes because they work. They communicate damage instantly. The real complexity, though, is in synchronizing them perfectly.
What do you mean?
Well, for a hit reaction, 3 different things have to happen at the exact same time. The monster's visual state has to change, that's the red flash. The camera object in 3DS has to momentarily shift, that's the screen shake. And the damage number has to update the state manager's zoo stand.
Yes.
Leaning on tropes is smart for efficiency, sure, but executing them with perfect sync across that whole tech stack, that's the achievement. And don't forget the death animation, a full rotation and collapse. That needs gravity simulation and collision detection so the model actually lands believably on the floor. So the visual synthesis is clearly robust. But, like we said, pretty graphics don't make a game. Let's get into the core challenge, which is Section 2. Building a whole tactical RPG combat system. Let's start with that engine, the speed-based turn meter. This is the heart of it, technically. A speed-based meter moves the game from just taking turns one after another to something more tactical.
Right, so every monster has a speed stat.
Correct. And in every single game cycle, its turn meter fills up based on that speed. Whoever hits 100% first gets to act. So the AI had to write this persistent high-frequency calculation loop, probably optimized inside ZooStan, that's constantly checking speeds, incrementing meters, and then triggering the next turn when someone's full.
That's a massive constant calculation happening in the background. If the AI had picked a less efficient state library, that game would just feel sluggish immediately.
Oh, absolutely. It would grind to a halt. ZooStan was essential for this.
If that core logic, the speed calculation, was slow, the whole thing just falls apart.
Completely. The fact that ZooStan has so little boilerplate means that when that combat loop updates the speed values, those changes are reflected in the visuals, in the UI, instantly. There's no lag. It proves the AI is prioritizing functional performance above all else.
And it's even more complex because it's not just about speed. It's managing unique skills and cooldowns. Each monster has 3 skills, different damage multipliers, cooldowns. That's a lot for the state manager to track.
It's a layered system. You've got 5 active timers for each character, really, 1 turn meter, and then cooldowns for the skills.
So how does it all fit together?
Well, the base turn meter determines who gets to act. Then, when it's your turn, you pick a skill. That action triggers a damage calculation, and at the same time, that skill's cooldown gets written back into the ZooStan state as, a number.
Like 4 turns or whatever.
Exactly. And as other turns pass, the logic reduces that number. And this is crucial. The UI component for that skill, which is rendered by React, has to read that cooldown state and then disable the button if the value is higher than 0.
And that instant disabling of the button is such a hallmark of good UI. It's that immediate feedback to the player that says, yes, the system heard you, and no, you can't use this yet.
And the AI nailed it. It's the visual side of the state management coin. The whole player interaction feels intuitive. You click a skill, you click a target. The AI handles everything else under the hood, managing who you've targeted, executing the attack, updating health, applying the cooldown, and then starting the whole cycle over again.
Okay, let's pivot to the opponent. The enemy AI is so often the hardest part of a turn-based game to get right. The source says the enemy just picks a random available skill.
Yeah.
So did the AI just punt on strategy here?
I'd say it prioritized creating a functional, unbreakable system over a challenging one. A truly strategic AI would need complex decision trees, right? It would check your HP, its own buffs, and try to optimize its damage.
Which would have taken way longer than 30 minutes to generate.
Way longer.
So the AI generated a simple but effective strategy. Wait for my turn, check what skills are on cooldown, and pick one at random. It's efficient, it guarantees the system works, doesn't get stuck in a loop, and it still provides a plausible opponent. It's a very smart compromise between complexity and speed. Efficiency over optimization. That seems to be the running theme here. Let's talk about that final layer of polish. The UI itself. You mentioned it earlier, but UI in a 3D space is notoriously difficult.
It is. It's a huge headache. You're constantly having to translate between 3D world coordinates where the monster is standing and 2D screen coordinates, which is where the health bar needs to appear.
And the AI generated these floating 3D health bars.
Right. And they're not just 2D overlays. They're actual 3.js geometry that are constantly being tracked and oriented to face the camera, so they're always perfectly readable.
And again, it styled them to match that specific Summoner's War look.
Exactly. You've got the clean green HP bar, the blue turn meter right on top of it, that circular level indicator. The AI had to manage the complexity of rendering all of that in 3D space,
Yeah.
while also feeding their fill state, their values, directly from the Zoo Stand store.
So if health drops by 10 points,
The health bar geometry has to update instantly to reflect that, with zero visual stutter. That tight coupling between the 3D engine and the lightweight state manager is really the technical highlight of the whole UI.
and that integration also extends to the player's skill bar.
Yep. A fixed, semi-transparent bar in the bottom right. We already talked about how it disables skills in real time. But the AI also included other essential features, like the battle log over on the left.
Which is so important for tracking what's happening.
Crucial. It gives you all that textual reporting damage numbers, who took a turn, what happened, that you need to actually follow the battle in a complex game.
So the AI didn't just build the game loop, it built the reporting and the ending too.
Correct. The win-loss conditions were hard-coded. When a monster's HP state in Zoostan finally hits 0, the system detects it, triggers the death animation, and then displays a victory or defeat message. It's a complete, contained loop. Visuals, mechanics, feedback, and conclusion. So let's take a moment and just synthesize the whole achievement. 30 minutes. We have a stylized arena, 2 animated 3D monsters with spring physics, a complex speed-based turn system, unique skills with cooldown logic, a functional enemy AI, tightly integrated 3D UI, a battle log, and win-loss conditions. The source material claims this completely shifts the creative bottleneck. It does. It fundamentally does. Game development is moving away from being a technical puzzle of integration, and it's becoming more of a high-level descriptive exercise. The AI has proven it can take a vision, described in words, and turn it into a working, polished 3D artifact using really smart architectural choices.
So all that time normally spent on asset pipelines, configuring state managers, wiring up UI,
It's just gone, virtually eliminated.
which means the most valuable skill for a game designer is maybe no longer pure coding proficiency, but descriptive clarity. You design the vision and the constraints, and the AI handles the grunt work of execution.
And the source material was clear that this 30-minute example is just the beginning. The next logical step is to scale this. Ask the AI for a full campaign, or for dozens of unique monsters, or to just generate a complete clone of a huge game like Summoner's War. The potential to scale complex systems from just a description, it feels like it's been unlocked.
That leads perfectly to our final thought for you to chew on. If an AI can build this complex 3D world and combat system in just 30 minutes from a simple description, what specific, deeply complex design constraint would you task it with next? Would you push it past that simple random enemy AI and ask for, say, an adaptive system that learns from the player?
Or maybe procedural map generation, where the layout changes based on your combat history.
Exactly. What is that next level of vision, that perfect blend of creativity and technical constraint that you would ask an AI to interpret and execute? Think about what you would build if you knew for a fact that the technology wouldn't fail to bring it to life.